Okay, testing 1, 2. I think we are live. Welcome. Okay, I'm just testing my stream health here. Stream health seems excellent. Just going to be saying something in the chat very quickly. Hello, class of 2021. Okay, today is differential calculus. All right, so with that, I believe you can see my screen. And I'm going to take you through something from the DBE SUP of 2018. And it's related to differential calculus. Okay, so we did a bit of differential calculus last week, and we're going to do some differential calculus this week for maybe 10 or 15 minutes, maybe longer. And so here's what we're going to do. Let's just underline the key components of this question. They say determine f dashed of x, so they want the derivative from first principles if f of x is equal to 4x squared. Okay, now before you start to attempt the question, I will attempt the question in black. I'm going to do some pre-work in blue. And here's what I would recommend. If you already know how to work out the derivative using your rules, do so. Okay, so in this case, the derivative f dashed of x is going to be 8x. Okay, it's going to be 8x. Now, why do I do this? I do this because when I'm working through, I want to be able to compare it to something to make sure that I'm correct. Now, another thing to think about is what type of graph is this? Okay, 4x squared is a happy-faced parabola, right? So that's f of x. And if that's the case, if I work out the derivative, what is the derivative of a parabola? Specifically a happy-faced parabola, I will have a straight line with a positive gradient. And you'll notice that this correlates to this. This is the equation of a straight line, mx plus c. And you'll notice it has a positive gradient. Okay, so whenever you are given any sort of derivative question from first principles and you can fathom what the derivative is going to be and what it should be in terms of the straight line and in terms of what can be, do so. And so now let's start by answering the question. And of course, the first thing you will probably write is this, right? You'll say, okay, my step 1, and I'm going to write it down in steps. Step 1, and I'm going to write this in black, because remember we said we would answer in black. So this will form part of your solution. Step 1 is you will write the definition, and you'll get 1 mark for this. Okay, and then we go to step 2. Now, how I like to break it down is I say, okay, step 2, work out f at x plus h. So you'll say, okay, in this case, f of x plus h is equal to, right? Now, f at x plus h means where I see x in brackets, I'm going to replace with x plus h. So this is the same as 4 into x plus h squared. And of course, I can expand this in the brackets using either FOIL or something known as SMS. Okay, you can use either one. I use SMS because it's quicker, right? So if I use my BODMAS, that 4 remains as it is for now. I square the first, right? So I'm going to use the SMS technique in this case, right? SMS. Okay. Just give me a second, please. Right, I square the first, and that becomes x squared. I square the last, and that becomes h squared. And then I take the first and I multiply by the second, and then I multiply by 2. So x times h is xh, times 2 is plus 2xh, like so. Okay, and then I can start to distribute the 4 into the brackets, right? Now, if I do that, what I end up with is, and I'm going to put it down maybe here, right? That becomes 4x squared plus 8xh plus 4h squared. Okay, and that's f at x plus h. That's step 2 done. The next thing I'm going to do is I'm going to work out f at x plus h minus f at x. Okay, so what is that going to be? Well, it's going to be this thing here. So let's just recreate it or grab it. So it's that. Let's put it down here. Then I'm going to say minus, and I'm going to open a bracket. And what I would recommend is whenever you have a minus, you should open a bracket. Okay, and what is f at x? Well, we know it's 4x squared. 4x squared. And of course, if I simplify this, if I bring this negative in, this becomes negative 4x squared. And what you'll notice is that this 4x squared and that 4x squared then cancel. And then what am I left with? Well, I'm then left with 8xh plus 4h squared. And then I'm going to factorize this. I'm going to pull out a highest common factor. So in this case, I can pull out 4h. And what am I left with? Well, I'm left with 2x plus h. Okay, that is step number 3. And now let's go to step number 4. And now I'm going to put this into the entire definition. So I'm going to say, okay, in this case, f dash of x is equal to the limit as h tends to 0, right? 4 into 2, 4h into 2x plus h all over h. Now what you'll notice is that this cancels with that because there's multiplication happening there. And now you'll notice that I can bring the limit in, and what this becomes is it becomes 4, because this becomes 0, 4 times 2x, which is 8x. And you'll notice that this here and this here are the same. So I know I'm on the right track. Now, if this was for 5 marks, you would have gotten 1 mark for the definition. You would have probably gotten 1 mark for that. 1 mark for doing this properly. 1 mark for doing this. And 1 mark for doing that. And that is how you do it. Okay, I just want to see if there are any questions. Doubt it. Analytics, viewers, no one's around today. Okay, so let's go to the next one. And now they're saying dx, x squared minus 2x minus 3, all over x plus 1, and they say determine. Now dx is another notation that says find the derivative. Now, first of all, we cannot find the derivative of this in this form. We need to be able to simplify this, right? Now what you'll notice is the numerator can be simplified. So my first step for 8.2.1, step 1, is let's simplify this. So let's keep it as dx. Okay, now if I simplify the top, I can then get x minus 3 into x plus 1 all over x plus 1. Okay. Now how did I do this? I just factorized the top. Now you can use any method to factorize, right? Doesn't matter. But what you'll notice is then I am able to cancel that out and that out. And I'm now left with differentiate with respect to x, x minus 3. Now in this case, your answer is then just the derivative of x is 1, and the derivative of minus 3, which is a constant, is 0. So your answer in this case is 1. And so in this case, you would probably have gotten a mark for substituting or factorizing, and a mark for cancelling out, and then a mark for working out the derivative, which gives you 3 marks in total. All right, so nothing too hard about this one. Let's go to the next one. Right, so let's just write this in black. Right, now they want the double derivative of f of x if f of x is root x, right? So the first thing we need to ask ourselves is, can I differentiate in this form? And the answer is no. So the first thing, my first step, is to make it into a differentiable form. So I say f of x can be written as x raised to the power of a half. Okay, this is using your exponent laws, so I hope you remember them. Now I can find the derivative. Okay, so I need to find the first derivative, f dashed of x. The half comes to the bottom, so that becomes a half x to the power of a negative a half. Okay, now this is my first derivative, and then of course I need to derive one more time because they want the double derivative. And then I say f double dashed of x minus a half times a half gives me a minus a quarter x, and minus a half minus 1 will give me minus 3 over 2. All right, and that is my answer for this double derivative. So you'll notice I put an arrow underneath. Okay, so that basically ends our little preparation or some of our practice for this jam or this session. And I hope you found this beneficial, and I'll see you next time. Ciao.